Okay, so I forgot to give you a problem to work on, so here it is. So I'm going to read it to you just so you have the setup. It says, define R as the region bounded above by the graph of f of x equal to x and below by the graph of g of x equal to x squared over the interval from 0 to 1. And it says find the volume of the solid of revolution formed by revolving this R region around the y-axis. And so that's what I want you to work on as practice. And let me know if you have any questions or if you get stuck on anything, or if you want confirmation that you got the right answer. Okay, so now the next topic and the last topic that we're going to cover in this section is how do we know which method to use? Should I use the washer method? Should I use the cylindrical shell method? Should I use the disc method? Which one should I use in a particular situation? So here are some things that you should know. Okay? Again, make sure that you understand, first of all, the type of region that you're in. So know the formulas that go with each method. Okay? So know those formulas. And then also understand that whether there's a concavity in it, is there a concavity in the, when you sketch it out, is there a concavity or not a concavity, but a cavity of some sort, or a part of the graph that's missing when you rotate it? So that's going to also tell you which one you should use. What else? Let's see. What else? Hold on a second. Let's see what else is here that they mentioned. So this is another thing. It really comes down to this, and I said this at the beginning. It might not have been in the beginning, but towards the beginning of these lectures for this section, is it really comes down to which way gives you an easier integral to evaluate. Okay, which one gives you an easier way to get to the answer? Usually there's one way that's easier and quicker than the other way. Okay, so keep that in mind. And also the other thing that the more you do these, the more you practice, the more you're going to be observant, and you'll observe certain things that come up, and you'll start to see, hey, I'm probably going to use the cylindrical shell method in this one, or you know what, I'm going to use the washer method in this one. Okay. So what I would do is basically make yourself a table, okay? So a table of values, sort of like this, right? So again, it's up to you to make your own table, but something that kind of helps you as far as what is typical, right? So if you want to copy this, or if you want to make your own table to kind of help study from, this is pretty much the flow chart, if you will. Okay? So, let's do an example of selecting the best method here. So we'll do this one. It says, for each of the following problems, select the best method to find the volume of a solid of revolution generated by revolving the given region around the x-axis, and set up the integral to find the volume. Do not evaluate the integral. Okay, so all we're going to do is we're going to set it up. And we're going to set it up and we're going to choose the one that we think is the best. Okay, so here's A. Okay, so for this one, we're going to rotate around the x-axis. So the first thing I would do is I'm going to sketch the graph, see what it looks like. So y equals x, that looks like this. And then, of course, 2 minus x is going to go like this. Okay. Oh, this is y equals 2 minus x. Okay, so that's a sketch of the graph. Okay, so now what's the shaded region? Well, that's the other thing. So in this case here, there's an intersection point. It's bounded by the graphs of this graph, and the x-axis. So again, so they don't tell us above or below. So look at this. So here is the region. So it's bounded by those three lines, the x-axis, this line, and this line. So that means the region that we want to rotate around the x-axis is this one. Okay? So look at this. So when we rotate around, how should we do this? Well, if you look at it, the easiest way to do it is use the disk method. Or no, actually, let's see here. No, actually, you might want to maybe the washer method, because if you go the washer method around, oh, hold on, no, you're going around the x-axis, hold on. So if you do, no, you could do the cylindrical shell method because you're going around, hold on, let me draw my x-axis, right? And we're going around, right? So we're going around the x-axis. And so we're going around this way. So that means I could use the cylindrical shell method and just go from 0 to 1. And I'm done. See, if I go this way, if I go the disk way, look at this. I'm going to be under this function from 0 to 1, and then I'm going to go under this function, the graph of this function from 1 to 2, and so I'd have to set up two integrals to add. I mean, you could do that, but it'd be a lot simpler just to do it with the cylindrical shell method and go from 0 to 1, and you're done. So let's see if that's what they did. Is that what they did? Yep, that's exactly what they said. Yep. So you could use either one. Like I said, either way is not particularly difficult. But when it comes to just if you're looking at the best method, the fact that one way uses two integrals and one way uses one, it's I guess better and easier just to deal with one, right? So let's set it up. Okay. So if we used the cylindrical shell method, this is the way we would calculate the volume. So it would go from 0 to 1, right? Excuse me. So we're going from 0 to 1. So this is, oops. So this is in the y direction. And then it's going to be cylindrical shell method, so it's going to be 2 pi 2 pi y. And since I'm dealing with two curves, right, it's bounded by two curves, so the height of my cylinders are going to be this function minus, so the top function minus the bottom function. So in this case, it's going to be 2 minus x minus x. Okay, so in this case, it's going to be 2 minus 2x dx. Okay, or if you wanted to, well, I'll leave it that way. You could factor out the 2 and then make that a 4. But, so, and then, if you use the other way, right, if you use the disk method that I first said, so that means your disk, you're going to go perpendicular, your rectangle is going to perpendicular to the axis of rotation. And so in this case here, you're going to go from 0 to 1 for the first one. And the formula that you're going to use is going to be what? It's going to be pi times x squared, right? Because it's the function squared. The disk method is always pi times the function squared, okay? Because you're doing the area of a circle. So it's pi r squared. So in this case, x, which is the function, r is the function, right? F of x squared. So in this case, it's f of x is equal to x. So it's x squared. And then you're going to add another integral from 1 to 2, and that's going to be what? From this one. So that's going to be pi times 2 minus x squared. Oh, by the way, don't forget your dx's. And that's it. So again, we're not solving them, but if you use this one would be the simpler way of doing it. Okay? But again, both of them don't look that difficult. Okay? So now, B. So what does B say? Okay, so here B says what? Well, they want the region bounded by the graphs of y equals 4x minus x squared and the x-axis. And again, we're going to be rotating around the x-axis, okay? So again, let's sketch the graph and see what it looks like. Well, this is a parabola. Okay, so it looks something like that. And so this is the region that we're bounded by. So the region that's bounded by this graph of this function and the x-axis. So it's going to be this enclosed region. And so we're going to rotate again. We're rotating around the x-axis. And so now on this case here, The easiest way to do this will just be the disk method and just go from 0 to 4. That would be the easiest way to do it. So in this case, I would do volume. And now here's the thing. The disk method is in terms of x. So we've got here, and the height is in terms of x. So it's going to be the integral from 0 to 4. And again, the disk method means that we're going to do pi f of x quantity squared dx. So we're going to do this squared. Okay, so it's going to be quantity squared dx, and that's the disk method. And that's the only one that I would do. I mean, that's the easiest one. Okay, here's one for you guys. And then, now again, I don't want you guys to set this. I don't want you guys to solve this. Just set it up with the integral, right? So set up the integral. And don't solve it, just set it up with the way that you think is the best way to do it, okay? And if you want to email me for confirmation, go right ahead. So here's the region, right? So they want you to set this up, and here's the bounded region, and it's going to be around the x-axis. So it's going to be the region bounded by y equals 2 minus x squared and y equals x squared. And we're going to go around the x-axis. So again, that's the region. So this is the region. So the region R is bounded by these two curves. So you have to figure out what that looks like. And then based on that, and the fact that we're going to rotate around the x-axis, and then decide which method you should use that would be best, and then write out the integral. Don't evaluate it, just set it up, and that's all you have to do. Have a great day.